So let's continue FRQ 3, right? So in this example, before I even start, I want to go straight into section C, right? C2. I want to figure out my concavity, right? So you may think this is the one I'm focusing on. No, it's this one at the bottom, right? It says describe how the rate of change of H is changing on the interval T1, T2. So T1, T2, if I go back to part C here above, T1 is G, T2 is J. So let's go to the graph. G and J. G and J is right here. So in this example, our rate of change is going to be increasing because this is concave up, right? So if I go to the question and try to answer it, this is obviously concave up, and you can say rate of change is increasing on the interval T1, T2. There you go. As simple as that, right? Remember, part C, section 2 is focused on concavity, right? Concave up or concave down, right? And this one right here, part C, section 1, this is focused on function behavior. So if I go back to the problem, right, I'm trying to figure out what's happening here. So if I may, right, erase this, according to this, right, the figure skater is doing rotations and going from the wall to the center of rotation, it's about 18 feet, right? But they also give me a piece of information here where it says where point B is at, it's always 3 feet from the center of rotation. So we include that, we have our two numbers, right? So from center of rotation all the way to point B, this is 3 feet, right? But what I want to do is figure out this point right here, all the way to the end. So all I have to do is just simply add 18 plus 3, and I'll get 21, right? So that's basically how you get this point overall, the length, right? From the wall. But what happens when this point goes from the right all the way to the left? Well, instead of adding 3, we're going to take away 3 from the 18. Meaning that this is going to be, let's say if B ends up right here, right? This is going to be 18 minus 3, which is 15, right? And then let me just put the note here. This is 18 plus 3, right? So there you go. We have our points, right? And if you want, instead of trying to figure this diagram like this from the wall going to the right, you can just turn it around and just consider the wall as ground, right? And you're going all the way to the top until you reach 21. Center point is 18 and minimum is 15, right? So why is that important? Because this is going to help us figure out our y values. So our y values right here, right? So now if I consider this and start putting my points, right? Right? So maximum is 21. So this is 21. This is 21. Minimum is 15. This is 15. And then 18 is what we consider our midline, right? And that's what it's telling us. It's our center point. So we already get a point for this. Just try to figure out the y's. And going from the y's, right? If you want, you can figure out the multiple choice, right? From let's finish up C, right? So here, from G and J, where was G and J? G and J are here, right? So this, think of the plus, 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 minus, minus, minus. So this is minus, 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 so it's decreasing. But look at the y's. So y's are positive numbers, so it's a positive and decreasing. And positive and decreasing, it's B, right? There you go, simple as that. But now, if I want to go back over here, right? If I go back over here, I could also solve for A, B, C, and D, which is from section part B, right? So the midline, which is D, is 18. The amplitude is what gave us the 21 and the 15, right? So what number did we add and subtract the 18 from, right? It was 3. So what else do we have? What else do we have? You get another point for that, right? What else does it have here, right? So it says here, 6 rotations every second. So 6 rotations every second, meaning that this is a frequency, right? So what I want to do with this 6 is just turn it into 1/6, which is going to be the period, right? So where does the period start from? So it says here, at time equals to 0, B is at the farthest distance from the wall. So if the wall is all the way to the left, you need to figure out what's all the way to the right. Or if you're looking at this diagram over here, you need to figure out what's all the way to the top. And the answer would be 21, right? So 21 is going to be the timer for my 0. So if I go down here and reorganize this, right? So that is going to be 1/6, meaning that my 0 is just going to go right there, right? So going from here, if I take these two and try to figure out, well, if this is half of the 1/6, all you literally have to do is just double the denominator. So this is 1/12, right? What about this one right here? Now if I have 0 and I have 1/12, double the denominator. So this is 1/24. And what about this one for K, right? This one's a little bit more challenging because for this one, you literally have to add 1/24 plus 1/12, right? Basically these two right here, this one and this one right here. So in order to get this, you have to have the same denominator. So this is equal to 1/24, and if I double top and bottom by 2, I have 2/24, which is 3/24. And if I try to simplify that, it is 1/8, right? So there you go, right? Nothing too fancy, just basically dealing with the fractions, right? So anyways, we got all the values for x. You get another point, right? So now, what am I missing? What am I missing? I have A, I have D, I'm missing C, and I'm missing B, right? So let's solve for B first, right? Let me erase this right here. Let me give myself some room, right? So if I focus over here, right? You have to remember the period is 2 pi over B. If I want to get the B value, I'm gonna have 2 pi over B over P, right? The period. So this is basically saying that I have 2 pi over 1/6. I have a fraction within a fraction. How do I get rid of it? Well, multiply by the reciprocal. This turns into 1. Multiply those. Now you have 12 pi. And there you go. This right here, 12 pi. But what about C? Well, in order to answer that one, I need to figure out it's talking about sine or cosine. So if I go to the problem, it tells you right here for part B that I'm working with sine. So sine, typically, when you're dealing with sine, you start off in the midline. So in our case, the only value that fits is, well, the G, right? Which is 1/24. So again, if it's talking about sine, you focus on the midline. Cosine, you focus on the maximum, right? And that's pretty much it. Good luck.